So, continuing with the summary and general description of a binary symmetric channel and writing down these relations, which are nothing but outcomes of basic probability definitions. So, if you want to have y naught can be due to this x naught or x1, they need to sum up, they happen individually, independent events. Then probability of receiving a receiving a symbol, say y, anyone, is given by receiving that due to this one, receiving again that due to that one. So this is probability of receiving a symbol. Probability of receiving a correct symbol is given by this into this will give you this, which is correct symbol, and this into this should give you this, which is again correct symbol. So probability of y1 given the right input was sent, probability of y1 given this input was sent. So this one and this one has to be accounted for to get this one, and same is for y1. So if we see this formula here, receiving the correct symbol bit, so you are transmitting a x0, so you should receive a y0. If you are transmitting a x1, you should receive a y1. So transmitting this should get this, not this. Transmitting this should get you this, not that. And 1 minus probability of correct transmission will give you probability of error. I hope I did that right. So probability of correct reception, if you transmit A given B, you use the joint probability, and these two events are independent events. So probability of having jointly both of them, probability of A into probability of given A B given that A had occurred. If they were independent, then it would fall down to probability of A into probability of B, because it does not depend on this. But if it is dependent, this formula exists, which is called Bayes rule. We can rearrange these, get this, and apply to our channel study. So let us go for an example rather than showing you the formulas. So here we are given a binary symmetric channel, and we have been given the transmission probability of 0. So the x0 is 0, and it is generated with probability 0.4 by the source, and x1 is signal 1, bit 1, it is generated by probability 0.6, transmitted by this. So why not happens given x1 has been transmitted with this probability, and so on. So they are given. So you have to find the error in channel. How do you find error in channel? As discussed, simply error in channel is that you transmitted this, and rather than receiving this, you received this. So you simply multiply these two. So 0.4 into 10 to power minus 6. 0.4 into 10 to power minus 6. So this is one kind of error. Another error would occur if you transmit this, and rather than receiving this, you transmit x1, you should receive y1, instead you received y0. So you multiply this with this, which is 10 to power minus 4 into 10 to power or into 0.6, you get the answer. And you have to write this, the explanation also, and explanation goes like this: probability of error is given by receiving a 0 if you send a 1. So if you send a 1 but you receive a 0, so this is the probability, multiply probability of this and transmission error, transmission probability, to get this part. And another error can occur, another separate error can occur if you receive a 1 and you send a 0. So this is basic probability formula. You just crunch the numbers, get the answer. And one more thing, in earlier video I gave an introduction to probability, review to probability, and it had got that it had that binomial theorem also. So x plus y to power k can be found like this. I remember it by a mnemonic way to remember. Bhai matlab brothers, no meal, no means they can't be together. So x and y are brothers, and k you remember, and this part I remember like this: ek E and K, ek on nak sak, and somehow you just make a mnemonic and remember this binomial theorem, and that binomial theorem can be applied to our theory to find probability of k errors in n bits. So that is Bernoulli's trial, and that becomes Bernoulli's trial. And let us go for another example. It is better to do exact questions rather than going into theory, because this is what will be asked mostly in the exam. Numericals, 90% will be numerical paper in your university exam. Rajasthan Technical University syllabus I am covering. So channel matrix is given to you in this question. Draw the channel diagram. So if you remember the general construct of channel matrix, this is probability of receiving a y1 given x1 was transmitted. So x1 was transmitted and y1 is received, so 1 minus p is associated to that. This is probability of receiving a y2 given x1 was transmitted. Given x1 was transmitted, y2 is received. X1 may be 0 or whatever by data, but its probability is given to you. Let's see where it is given. It is given here, and then so quickly I'll run you through this. So probability of y1, y2, y3 due to x2. So x2 can make y1 no 0, so no arrow will go here towards y1. X2 and y2 and y3, y2 and y3 are generated. So probability of x2 making y2 is p. That's why I wrote p here. I wrote p here, and I wrote minus 1 minus p here, because probability of generating a y3 due to y2 x2 is this. So after drawing this and identifying this, that this is E, and that's why it has been named erasure channel. This kind of channel is erasure channel. You can memorize it by its drawing. So let us first draw the channel diagram like this, and then extra information I populated like this. Then go to the second part. They are saying that probability is 0.2, sorry, p is 0.2, which is here. Plug it in and get the values here. Then it says the source has equally likely output. Source is this. Source generates x1 and x2, and these two are equally likely. That means both will have equal probability. Sum of input probabilities will be 1, so 0.5 0.5 to both. That is what this line wants you to get out of it. Find the probabilities of outputs. What are the probabilities of output? Probability of this output is, what is the probability of y1? Probability of y1 is simply, if you send this and the channel probability is this, so you get 0.4. This is the answer. So straight away you can get the answer. Probability of this is this into this, then you can get this one, this into this, and then you can get this one. So this into this plus this into this will give you this one. Similarly, this one will be given by this into this, which numbers are same, so it will be 0.4 again. I think I have done it here. So probability of y2 will be two ways it can be generated, and you sum it up and get 0.2, 0.4 for others. So that is the correct answer, and you can do it by general method also. You can write the matrix. So better is you just get them with your basic learnings that you had in probability. With general matrix, if you try to write at that time, you will not be able to manufacture. So you have to remember it, but better not to remember, just get the answers in a derivative way using your basic probability theory learnings. You can watch my video, or you can watch any other YouTube video to develop your probability theory, and then it is easily applied onto the theory developed here in information theory subject. Thank you.